Okay, we're on to our last section of chapter 9, and it's over angles of depression and elevation. So think depression is something where you're looking down. So if you were to look at something dead on at eye level and then you were to look down, that's your angle of depression. So think down, depression. Or if you're looking at elevation, think of elevate. So if you're looking at something at eye level, but then you look upward, so that's angle of elevation. So angle of elevation is an angle between a horizontal line and the line of sight where the angle is above the horizontal line. That's above. Angle of depression is an angle between a horizontal line and a line of sight where the angle is below. So you have angle of elevation going upward and angle of depression going downward. So think of where you're looking at. If you're looking from the hot air balloon down to the person, or you're the person looking up at the hot air balloon. So a couple of things to notice. Our two horizontal lines they look like they'll never touch each other. These two horizontal lines are parallel to each other, and the angle of elevation and depression are congruent. 38 degrees and 38 degrees, they're congruent. Angles that do this are called, these look very similar to what we've talked about before, they are alternate interior angles. If you draw a vertical line, then a right triangle is formed. So in this case, if I were to draw a line from my point of view down to the floor, I have a right triangle formed here and a right triangle formed there. So let's go through our example. So angle 1, I'm at the top, eye level to the top of the mountain. I'm looking down at the person, going downward. So if I'm looking down, then this is an angle of depression. Now angle 2, I'm the person looking up at the mountain, so then going upward, that is angle of elevation. Now angle 3 is different. It might be eye level, but this time I'm looking down at the house. So looking downward at the house, that is your angle of depression. And then angle 4, I'm at the house looking at the person. I'm looking upward from eye level. So if I'm looking upward, then I have an angle of elevation. Okay, let's try a couple of examples and we'll piggyback back and forth because this section is not very long. So A says a palm tree casts a shadow. So it casts a shadow of 18 feet long. So remember, shadows are along the floor, so this is 18 feet. And the angle of elevation. So if I'm going by angle of elevation, am I going to go up and look down, or am I down looking up? Elevation means I'm at eye level looking upward. So my 25.7 degrees is here. So looking upward. And then I want to find the height of the tree. So how tall is the tree? So now this looks similar to our trim function. So I don't have a hypotenuse. So this is, I'm going across, x is O, and then 18 degrees is A. I don't have a hypotenuse, so I'm going to use tangent, or TOA. So I'm looking for tangent of 25.7, and it's equal to x over 18. So solving for x, I have 18 and 25.7 equals to x. Okay? So number B, you will try on your own. See what you get. We're going to page 29. page 29, I have a few more examples. So let's try D. You're going to try C on your own. So let's try D. D says a ladder leans against the wall, and the base of the ladder is 5 feet from the base of the house. So this, from the house to the ladder, is 5 feet. And then it's a 20-foot ladder leaning against the wall. So that looks very much like a right triangle, where this is my hypotenuse. So what is the angle formed by the ladder and the ground? So where the ladder touches the ground. So this is your x degrees. So now I'm actually going to be using inverse because I'm looking for an angle. So let's label our sides. And crossing that is O. It's really dark on that side. And then I have my hypotenuse, and adjacent is 5. So the only one that has A and H together is but I'm looking for an angle, so I'm using inverse. So cosine, or inverse cosine, and then I have adjacent 5 all over 20. Okay, to equal X amount of degrees. And if I were to type this in my calculator, I should get 75.5 degrees. Okay, so try E. It's very similar on your own. And let's go to F to do together. So, I have a 2-meter total level. So that means this part right here is 2 meters. And filming the lift off the Space Shuttle at point 750 meters from the launch pad. The camera's angle of elevation, so it means looking upward, the shuttle is 32, so that theta is 32 degrees. And so the camera's angle of elevation is 32 degrees at this specific time. I want to find the height of the shuttle. So I'm looking at this height, the height of the shuttle here. So I have this right triangle formed. Let's not worry about the 2 degrees at this moment. But I have 750, and then I have X. So I have across, X is my opposite, and 750 is adjacent. So I don't have an hypotenuse, and the only one that doesn't have the hypotenuse is TOA, or tangent. And I'm already given, so I'm finding a side. So I have tangent of 32 degrees equal to O over A. So X all over 750. So remember, these two can switch places if you notice that shortcut. So I have X equal to 750 multiplied by 750. So I have X equals 750 times tangent of 32. Okay? Equal to equals, in the calculator, 468.7. But I still have to add these 2 degrees here, because that's part of the height. So I still have 2 degrees, or 2 meters here. So I have 468.7 plus 2. So I'm left with 470.7. Okay, so that was a little confusing, but you're solving it the same way with this triangle in mind. And you're trying to find X. The last thing you got to do is just add the remaining 2 meters. Okay, so let's try A, and this time it helps to draw a picture. I don't have a picture drawn for me, and I need to round to the 10th place. So A says a skateboard ramp at a park has an inclination of 54. So if I have a ramp, it's very much like a right triangle, and it has an inclination to an incline. So that means I'm going upward. If I'm going upward, that means the angle of elevation at 54 degrees. And the base is 12 feet long. So what is the length of the ramp? Length of the ramp. So I'm going to label my sides. Switch markers. So across from 54 is O, 12 is A, My hypotenuse h, I don't have an O involved, so the only one with A and H is cosine. So I have cosine of 54 equal to A, which is 12 over x. And that trick where I have x on the bottom is where I have to switch places. So x equals 12 over cosine of 54. And rounding to the nearest tenth, if I were to type this into my calculator, I have 20.4 feet. So see if you can try B and C on your own. And that actually concludes our notes. We have a practice page on page 30 where it says 10 questions. We have actually fewer than that. So that concludes our last chapter of notes over angles of elevation and depression.